Hi everyone, welcome to my channel, Tutorlini Test Prep. Today we'll be going over Ottocento number 5, Function Translations. The goal of the Ottocento course is to teach students everything they need to know about the digital SAT math exam. Please see the link in the description to download this video's worksheet for free. Let's get started. Okay, so the very first thing we're going to talk about is the horizontal translation, which we will represent with the letter H. So let's say the red function in the middle is our starting function, and that has an h value of 0. The one on the right is moved 5 overs to the right, so that has an h of 5. So when h is equal to 5, that means to shift our function 5 units to the right. The reason why positive 5 tells us to go to the right and not left is because right is the positive x direction. The green one, on the other hand, has an h of negative 5, which tells us to shift the function 5 units left. And again, we use negative for left because left is the negative x direction. So let's quickly sum that up. So when h is positive, we shift the absolute value of h units right. When h is 0, there is no horizontal shift. And when h is negative, we shift the absolute value of h units left. So you got to be able to go back and forth between these very quickly. So let's do a couple examples. If h is positive 6, okay, 6 positive x, that's to the right. So that means to shift 6 units to the right. If h were negative 8, that's the negative x direction. Okay, so that's left. So that would mean to shift 8 units to the left. I don't need that negative sign. We just take the absolute value when we're talking about distance. Similarly, if I had a shift of 9 units left, that would be an h of negative 9. And if I had a shift of 3 units right, we could figure out that that is an h of positive 3. Okay, now we're going to talk about the vertical translation, which we will use the letter k for. So let's say the red function is our starting function, and that has a k of 0. So the blue one went 4 up. So we would say k is positive 4. And the reason a positive value tells us up and not down is because the positive y direction is up. So y gets bigger as you move up. So conversely, if we shift it 4 units down, that would give us a k of negative 4. And the reason why a negative k value tells us down and not up is because the negative y direction is down. So let's sum that up again really quickly. So when k is positive, we shift the absolute value of k units up. When k is 0, we have no vertical shift. And when k is negative, we shift the absolute value of k units down. Once again, you need to be able to go back and forth between the two interpretations very quickly. So if we have a k of 5, that means to shift 5 units up. If we have a k of negative 7, that means to shift 7 units down. If we were told in a problem that we had a shift of 2 units down, that would mean that we have a k of negative 2. And if we were told in a problem that we were going to shift 1 unit up, up is the positive y direction, so that would mean k is positive 1. Great, let's keep going. So one final thing is that you can have any combination of both a horizontal and a vertical translation when you see a translations problem. It doesn't just have to be one or the other, although it often is on the SAT, just horizontal or just vertical. Sometimes it can be both. So look at this question. So if we look at these two vertices and we try to move the red one to where the blue one is, we have to move one right and I think 5 up, 4 up. So h would be to the right, so positive 1, and 4 up would be k of positive 4. Let's look at another one. So let's say we're going to move the red on top of the green. So we're going to look at these two vertices, and we're going to move, I think, 2 left and 6 down. So left is the negative x direction, so that's horizontal. So h would be negative 2, and k would be negative 6 because down is the negative y direction. So sometimes you can have both a horizontal and a vertical translation in a problem. So skill number 1 is translations for explicitly defined functions. So what the heck is an explicitly defined function? Well, it's a function where the dependent variable, that's y, is expressed in terms of the independent variable, that's x. In other words, y or f of x is by itself on one side of the equation. So for example, y equals 6x minus 8. That's an explicitly defined function because y is by itself on the left side of the equation. F of x equals 4x squared plus 3x minus 15. That is also an explicitly defined function because y or f of x is by itself on one side of the equation. So what we do when we want to translate an explicitly defined function is we figure out our h and k and we use the following expression. F of x minus h plus k. This shows up a bunch, and you definitely have to know this, so please write this down. I want to point something out too, as with any time you're working with constants, if there's a minus sign in front of the constant, you have to change the sign when you are both reading and inputting the number into the equation. And if there's a positive sign in front of a constant, you have to keep the sign the same when you are putting the number in and reading it. So just be careful when you're working with horizontal translations, you got to change the sign. And when you're doing with the vertical translation, we keep the sign, both when we're writing and reading these types of expressions. You'll see what I mean in a minute. Let's do some problems. So this guy, it says the function f is defined by f of x equals 8 absolute value of x. The graph of y equals g of x is the result of shifting the graph of y equals f of x down 3 units. Okay, so that's important. We should underline that. Down 3 units. And they don't mention any horizontal shift. So h is just 0. So we don't have to worry about h. And k is down is negative. So negative 3. So just write that down before you do anything, because I feel like if you just don't have that written down, you just start looking at the answer choices or rushing into the problem, we're going to make a mistake. So make sure you write that down before you do anything. Now we're going to do f of x minus h plus k. There is no horizontal translation in this problem, so we can just cross that out. And we're going to input our k of negative 3. So plus negative 3, that's the same as just minus 3. See how the sign, remember I said we keep the sign for k? See how it stayed the same, negative 3, and then in the expression, it's minus 3. And now, this one's not so bad. We're just going to now substitute whatever f of x is. F of x is 8 absolute value of x. So we get g of x is equal to 8 absolute value of x minus 3. And that's looking a lot like answer C. So you can see how this would maybe get really confusing if we went straight to the answer choices. Writing this down carefully and going through this very systematically makes these problems a lot easier. All right, let's do another one. So the function is defined by x minus 3, x plus 5, x minus 4. In the xy plane, the graph of y equals g of x is the result of translating the graph of f of x up 2 units. What is the value of g of 6? Okay, once again, we have no horizontal shift. So h is going to be 0. K is going to be positive 2 because up is positive for vertical shifts. We're going to take out our expression f of x minus h plus k. Once again, we don't have a horizontal shift. We got lucky for this one, so we can cross that out. And the k is 2, so we're just going to put f of x, g of x is equal to f of x plus 2. Now we're going to substitute in whatever our f of x is. So g of x is equal to, and again, if you wanted to, we'll do this in a minute, but if you wanted to do this on Desmos, that would be your input for Desmos. And so our function is going to be g of x equals that big mess and then plus 2 at the end. All we did was replace the f of x with what the problem told us f of x was equal to. And now if we want to find g of 6, that thing inside the parentheses tells us our x. So we're going to replace all the x's with 6's. And if we put that in a calculator or did that out by hand ourselves, we should get 68. So the answer for this one would be 68. So you see, Desmos can be really helpful for these guys, but just be careful because sometimes the problem doesn't give you the function notation. So like, you still need to know f of x minus h plus k so that you know what to type into Desmos, if that makes sense, right? You're not going to know what to type into Desmos if you don't understand f of x minus h plus k. So I made other videos about this, but just quickly talking about it. If you type in f of x and then unhighlight it so that you can't see it anymore, you just click on that little circle. See how it's like gray? That's because I clicked on it. And then you put in your function translation. In our case, it's g of x equals f of x plus 2. And then I could find anything I want about it. We wanted to find g of 6, so I just typed in g of 6. And I got 68, and I plotted it so you can see that 6, 68 is indeed on the graph. So really looks like we did a good job. Again, don't rely on Desmos too much because you have to know, you still have to understand f of x minus h plus k so that you know what to type into Desmos. Okay, let's do another one. So let's see, we have this function and we're translating it down 3 units and right 4 units. Okay, so right is positive, so h is positive 4, down is negative. So k is negative 3. And it's asking us two things. Why don't we first try to figure out what g of x is? So we're going to take out our equation again. Once again, f of x minus h plus k. And so it should be f of x minus 4 and then plus negative 3, or in other words, just minus 3. So see how the 4 in the expression changed to minus 4, and then the negative 3 we keep. So that one stayed the same. It's still minus 3 when you write the function notation. And let's see. So now to find f of x minus 4, what we do is we take everywhere we see an x in the original expression and we replace it with what's inside the parentheses, x minus 4. So that's going to look something like this. 6 times x minus 4 in parentheses plus 7. And then we still have that minus 3 on the outside. You don't need those brackets there. I just put those there to show you guys that that whole thing inside the brackets is f of x minus 4. So you just replace x with whatever's inside the parentheses. In this case, x minus 4. Everywhere you see an x, put x minus 4. Okay, now we distribute and we combine the like terms. And I believe that should give us 6x minus 20. So that was a lot of work, but we have our function 6x minus 20. So now if we want to find g of negative 3, we can take that function and plug in negative 3 for x. So we do that, and we get negative 18 minus 20, which should give us negative 38. So the answer to that first part would be negative 38. And now it says, what is the value of x when g of x equals 10? So this is really important. We're not going to plug in x as 10. We're going to make g of x equal to 10. So where g of x is on the left side, we're going to replace him with a 10. And now we're going to solve this. So to do that, we're going to add 20 to both sides. We get 30 equals 6x. Now we're going to divide both sides by 6. And we should get x equals 5. Let's go ahead and resolve this example using Desmos together. Okay, everybody, so first thing we're going to do is we're going to type in our original function, f of x equals 6x plus 7. Now we had to still do those first couple steps where we figure out the horizontal shift and the vertical shift. So h is 4, so we're going to, and k is -3, so we're going to write g of x equals f of x minus 4 minus 3. And we're going to unhighlight, we're going to click that red circle to unhighlight that original function because we don't care about him. Now if we want to find g of -3, we can just type that in. Ooh, I must have made a mistake here, hold on. Great, so we get -38, which I think is what we got. Now if we want to find when g of x equals 10, so we can just type in g of x equals 10. And if you want, you could just put y. How about I do that? And you could click where it intersects, which is right here. And the value of x when g of x equals 10, you can see is 5, which is what we got. So once again, Desmos can be a huge help for these types of problems, guys, but you're not going to know how to be able to leverage Desmos if you don't understand what h, k, and f of x minus h plus k are. So you got to make sure you know how to at least do those first couple steps before you jump to Desmos on a lot of these. Let's go back to the slides. Okay, skill number 2 is translations for implicitly defined relations. So what the heck is an implicitly defined relation? Well, it's a relation where the dependent variable y is not expressed in terms of the independent variable x. In other words, y or f of x is not by itself on one side. So it's kind of almost the opposite of the type of function we were looking at, the type of relation we were looking at before. So 5x plus 8y equals 10. That's an implicitly defined relation because, as you can see, y is not by itself. It's on the same side as an 8 and a 5x. Similarly, over here, x squared plus 3 equals y minus 6x plus 19. Same deal. The y is not by itself on one side. It has a minus 6x and a positive 19. So that would be a good example of an implicitly defined relation. So why are we going through all this? Well, there's a pretty different strategy that you have to use when you come across these kinds of relations on the digital SAT. So let's say we want to carry out a translation on an implicitly defined relation. Here's what we do. So we replace all the x's with x minus h, and we replace all the y's with y minus k. Please write this down because this is brand new to the digital SAT. So this might be confusing because, as we were saying before, remember there was like a plus k earlier, but now you're probably thinking, Kyle, now there's a y minus k. Well, it's because the y is in a different spot than in the explicitly defined function. So you have to do things a little bit differently. So try not to let that confuse you. Just note when you're going through this that when you're finding x minus h and y minus k, now both signs have to change. So let's look at an example. So the graph of 5x plus 8y equals 10 is translated left 2 units and up 6 units. What is the x-coordinate of the x-intercept of the resulting graph? Okay, this is a very tricky one, and probably wouldn't have one this complex on the digital SAT, but this is a good example to kind of show you how this strategy works. So first we're going to find h and k. Well, left 2, so that means h is -2. Up 6, that means k is 6. So we write that down. Then we're going to replace all the x's. First, we're going to find x minus h. So x minus h is x minus -2. So that's x plus 2. And then y minus k is y minus 6. So that's just y minus 6. And now remember our strategy. We're going to replace all the x's with the x minus h, which in this problem is x plus 2. And we're going to replace all the y's with y minus k, which is in this problem y minus 6. So we get this new relation 5 times x plus 2 plus 8 times y minus 6 equals 10. And this is actually how the digital SAT expects you to do it. So unfortunately, even though it's a little bit strange, this is something you got to know. So now we want to find the x-coordinate of the x-intercept, and we could just put that in Desmos if we wanted to. And again, just pay attention, both signs changed, not just the horizontal, both the horizontal and the vertical signs got changed. So pay very close attention to that, x minus h and y minus k. All right, so we want to find an x-intercept, so we're gonna plug in y equals 0, as with any time we want to find an x-intercept from an equation. So we distribute 5x plus 10, and then that guy on the right becomes negative 48. We combine the like terms, we get 5x minus 38 equals 10. We add 38 to both sides, and we get 5x equals 48. And now we're going to divide both sides by 5, and we get x equals 9.6. So that would be our answer, 9.6. Very, very involved question, but I hope it showcases this strategy well. Replace the x's with x minus h, replace the y's with y minus k. Let's go ahead and resolve this example really quickly using Desmos. Okay, everybody, so once we got that first step done on the actual test day, where we figured out the horizontal and vertical shifts, we could just go ahead and type this in. Desmos will plot it for us, and we can find both the x and the y-intercept just by clicking. So the x-intercept is 9.6, that's what we got before, and the y-intercept is 6. Again, Desmos is super helpful, but you're not going to know what to do if you don't understand the strategy that we just went over and what h and k are. So you got to be really careful that you don't make a sign error coming up with h and k, and that you don't make a sign error plugging it into the expression. It's really easy to like, oh, it's 3, but I put negative 3. It's really easy to make those kinds of tiny mistakes. So please try to be careful. Okay, let's go back to the slides. Okay, we got another one here. So the graph of 7x minus 2y equals negative 18 is translated right 5 units in the xy plane. What is the y-coordinate of the y-intercept of the resulting graph? All right, so right, that's horizontal, and that's in the positive direction. So h is going to be 5. K is going to be 0. It doesn't mention any vertical shift, so we don't really care about k for this. And we want to find x minus h so that we can replace it. So x minus h would just be x minus 5. Now we're going to replace all the x's with x minus 5. So we do that, and we get 7 times x minus 5. Everything else stays the same. Minus 2y equals negative 18. Now we're going to go and find the y-intercept. So to do that, we're going to plug in x equals 0. And we get 7, 0 minus 5. That should be negative 35. Now we're going to add 35 to both sides, and we get negative 2y equals 17. And now we're going to divide both sides by negative 2. And we get negative 17 over 2, or negative 8.5. And that would be our answer. Great. And once again, as you can see, Desmos would be a huge help for this one. Once you figure out that new implicit equation, you can just type it in and figure out any intercept or any point on that graph pretty quickly. Okay, skill number 3 is translations using special points. So we can track translations on certain relations by paying attention to special points that always move with the function. On the digital SAT, the ones you want to be concerned with are the vertex of a parabola and the center of a circle. So both of these points move as the function or relation moves. So if you look at the original vertex and the final vertex, or the original center and the final center, you can figure out what the function or relation translation was. And we're gonna go over this in a future video, so I'm just kind of gonna gloss over this. Vertex form of a parabola is y equals a times x minus h squared plus k. You have to have that, know that by heart for the test. The equation of a circle is x minus h squared plus y minus k squared equals r squared. Now, these h and k is not referring to necessarily horizontal and vertical shift. H and k in the first one are referring to the coordinates of the vertex, and h and k in the second one are referring to the coordinates of the center of the circle. So don't let that confuse you. It's not the same h and k. We just happen to use the same letter for these notations because they're all closely related. And once again, notice that if we have a minus sign, the sign gets changed, and if there's a plus sign, we keep the sign. And then for the equation of a circle, we got two minus signs, so both of them get changed. So just be really, really careful of those minus signs. Like, don't change the sign when you're not supposed to, and don't keep the sign when you're not supposed to. If there's a minus sign in front of the letter, the sign of the number gets changed. Great, let's look at this one. So the equation above can be represented by a parabola in the xy plane. The parabola is then translated so that the vertex is at 0, 0. Which of the following best describes the translation? Wow, what a tricky question. First things first, I'm going to look at those numbers kind of inside the quadratic equation to try to figure out the vertex. A lot of people would say -6, -4. But remember, there's a minus in front of that h in the equation. So that 6, that -6 has to be changed. So the vertex of that equation is actually 6, -4. It's not -6, -4. It's 6, -4. You have to change the sign of that first guy. Okay, so the new vertex, they told us, is 0, 0. What we're going to do is, to figure out the shift, I mean, there's a bunch of ways you could think about this, but you could do new minus old. So for the x direction, I'm going to do new minus old. So 0 minus 6, which gives me -6. So we're going to go 6 in the negative direction, negative x direction. And the y direction, we're going to do 0, new minus old, 0 minus -4. So that's 0 minus -4, 0 plus 4, which is 4. So that's 4 in the positive y direction, which gives us answer choice B. Graphing this might have been of some help too, but regardless of what you did, a lot of people would have fell for this trap answer C. Do you kind of see how, like, if you went from 0, 0 to 6, -4, C would be right? Like if you went from 0 to 6, that's 6 in the positive x direction, and then 0 to -4, that's 4 in the negative y direction. But the question didn't say that. The question says it's then translated to 0, 0. So actually the old vertex is the one in the equation, and the new vertex is 0, 0. So just pay very close attention to how the question is worded, because there's definitely going to be some convincing trap answers in the answer choices. So just be careful. Great, let's look at this guy. So the equation above represents circle A. Circle B is obtained by shifting circle A right 5 units in the xy plane. Which of the following equations represents circle B? Okay, so first of all, square root of 49 is 7, so the radius is 7. And the center, we're going to look at kind of the numbers inside there. And remember, we have to change the sign for both of them. X minus h squared plus y minus k squared. They got minuses in front of them. So there's no number next to the y. So I think the center is going to be -3, 0. Because that positive 3 gets changed to -3. 0, it changed the sign. It's still just 0. And we want to shift it 5 units to the right. So what we're going to do is, that's an h of +5. So we're going to do 5 in the positive x direction. So we're going to add 5 to our x. And that gives us a new center of 2, 0. And the radius is the square root of 49, which is 7. So now we're just going to go through and see which one of these has a center of 2, 0. It seems like they all have a radius of 7, so that's not something we need to worry about. Well, the first one, we changed the sign. It's 2 and -5, and we changed the sign of both of those. So it's -2, 5. So that's not right. I think the second one is 0, and then -5 changed the sign, +5. So it should be 0, +5. Also not right. Let's look at the next one. That would be -2, 0 if you change that sign, which is not what we want. So let's look at D. D has a center of 2, 0, and the radius is 7. So it's looking like our answer is D. Great. And again, Desmos can help on these questions. Desmos will plot the vertex, but it doesn't plot the center. You can kind of eyeball the center pretty quickly, but it's probably more helpful on the quadratic questions than the circle questions, but you can use it. All right, this one's really common in the Blue Book tests. And Desmos is really helpful on these, but let's go over how to do it by hand just for the sake of it. The function g is defined by g of x equals f of x plus 7. For a value of x, does g of x reach its minimum? Okay, so first of all, f of x minus h plus k, right? So there's no number on the outside, so there's no k, but there's an h. And remember, f of x minus h plus k. So there's a minus in front of the h, so we have to change the sign. So it's not 7, h is actually -7, which in other words is a shift of 7 units left. Now we're going to find the x-coordinate of the vertex, which we also call h, of the original parabola using, because it's in standard form, we're going to use h equals -b over 2a. A is 3, b is -60. So we plug those numbers in, and we should get an x-coordinate of that vertex of 10. So now we've got an old vertex of 10, question mark. If you want, you can go plug in x is 10 and find it. But it doesn't matter to the question because the question is just asking us what value of x. And it's going to get shifted 7 units left in the negative x direction. So we're going to do -7 to the x. And our new vertex is 3, question mark. Again, we don't care what that y coordinate is. It's not going to help us answer the question. So the answer is A. And once again, I made a whole another video about this. I think it's called Desmos minimum and maximum, and Desmos function translations. Please check those out. The one we just did would have been much easier to just do on Desmos. Again, just trying to get you guys prepared in case you come across like a harder question like some of the ones we were going over before. Always better to be over-prepared than under-prepared. Okay, great. Now it's time for the final review. Remember to download the free final review worksheet using the link in the description. Try to complete the worksheet yourself before watching the rest of the video. Be on the lookout for a pinned comment with more helpful links about today's topic. Let's switch over to the whiteboard and get started on the final review. Okay, let's get started. So this first one gives us a function and it wants us to, we want to take that function and we want to shift it up 2 units. So it doesn't mention any left or right, so h is just 0. Up is the positive y direction, so that would mean k is 2. So we're going to do g of x equals f of x minus h plus k. We don't have an h, so we can just kind of ignore this guy. So g of x is equal to f of x plus 2. F of x is 5x to the fourth, so now we just sub that in here. And we get 5x to the fourth plus 2. And let's see, that should be our answer. I think that's answer choice C. I encourage you to go ahead and plot the original and plot each of the answers to kind of verify for yourself that C is the right answer. It's the only thing that was done to it was moved up 2. Great, let's keep going. Okay, so this one we have another function, and we're going to move it left 5 units. Okay, so it doesn't mention any up or down, so k is just 0. Left is the negative x direction, so that means h is negative 5. And we're going to once again do g of x equals f of x minus h plus k. And we get g of x, there's no k, right? So we can just kind of get rid of this guy. And we get f of x minus negative 5, which is really x plus 5. Remember, the sign of h gets changed. And now to find f of x plus 5, we just find everywhere there's an x in the original expression and replace it with x plus 5. So let's do that now. We should get g of x equals 3, 2, and then there's an x in the exponent, so we put an x plus 5 in the exponent. And that gives us answer choice B. So you see there's a lot of convincing trap answers here. Lots of people might have made a sign error. Lots of people might have been unsure if it goes in the exponent or not. Whenever you have like an expression inside the function, you find everywhere there's an x in the original equation and replace it with that. So we placed wherever the x was, wherever the x's are, we replaced it with x plus 5. Great, very good. And again, you can graph this on Desmos to verify for yourself that it gets moved left 5 units. Great, let's look at number 3. So we have this function, and it says we're going to move up 8 units. So that is, we got no h, and k up is positive y direction. So we have positive 8. So we're going to do g of x equals f of x minus h plus k. We don't need to worry about h because there's no horizontal shift. So we're going to do g of x equals f of x plus 8. So g of x is equal to whatever that f of x is, so x root x plus 5, and then that whole thing plus 8. Now we're going to come over here and do g of 4. And we replace all the x's with 4. So 4 root 4 plus 5 plus 8. So that's 9. Square root of 9 is 3. 3 times 4 is 12, which I think is 20. And that should be our answer. This would have been a pretty good one for Desmos. Why don't we check our work really quick? So f of x equals x square root x plus 5. G of x, we had to come up with this ourselves. F of x plus 8. And we can kind of verify for ourselves that we did a good job coming up with the expression f of x plus 8 because it looks like it moved up on the picture, right? So that's a good sign. And we want g of 4, which is 20. Okay, so we did a good job. Great. Okay, let's move back. Let's look at question 4. Okay, so this one, we have 2. So we have right 3 units and down 9 units. Okay, right 3, that's h equals positive 3, and k equals negative 9. G of x equals f of x minus h plus k. So that's f of x minus 3 plus negative 9, or in other words, just minus 9. Now to find f of x minus 3, we replace the x with x minus 3, so it's negative 4 x minus 3 minus 7. And then that's our f of x minus 3, and then we have the whole thing minus 9. And now we should get negative 4x plus 12 minus 7 minus 9. And that gives us negative 4x 12 minus 7 minus 9. That's just negative 4. So that's negative 4x minus 4. And now we're going to find the value of x when g of x equals negative 8. So we're going to do negative 8. So we plug that in over here. Hopefully I didn't make a mistake or anything. And we get negative 4x minus 4. So we add 4 to both sides, and we get negative 4 equals negative 4x. Now we're going to divide both sides by negative 4, and we get x equals 1. Let's check it using Desmos. So f of x equal to negative 4x minus 7. I'm going to go ahead and, well, let's first do g of x equals f of x minus 3 minus 9. Unhighlight f of x because we don't care about him anymore. And g of x equals negative 8. If you want, you can just type in y. And zoom in, click, and x is 1 when g is equal to negative 8. Great, looks good. Okay, let's go back here. Okay, this is implicit, so we're going to have to do some x minus h, y minus k stuff. So first one wants us to translate it left 5 units. So h is just negative 5. And x minus h is going to be x minus negative 5. Or in other words, x plus 5. So now we're going to go and we're going to replace every x that we see. We don't have to do vertical because they don't mention that. With x plus 5. So 4x plus 5 minus 3y equals 10. And now they want us to find the x-intercept. So we're going to plug in y equals 0. And we get 4. So this whole guy just kind of goes away. Negative 3 times 0 is just 0. And we get 4x plus 20 equals 10. Subtract 20, we get 4x equals negative 10. And we get x equals negative 10 over 4, which simplifies to negative 5 halves, which is also negative 2.5. So either of those would be acceptable. Why don't we check it using Desmos? So we're going to do 4, hopefully we did this right, x plus 5 minus 3y equals 10, and we want to find the x-intercept. Negative 2.5, again, just double check. Okay, 5 left, that's an h of negative 5. And then x minus h. X minus negative 5, that's x plus 5. Looks good. All right, let's come back over here. Let's do number 6. Okay, so for this one, we're going to go up 2 units. So h is 0, no horizontal shift. We're just going to make k up is positive, so positive 2. And we're going to do y minus k, which is just y minus 2. So now we're going to find all the y's in the original equation and replace it with y minus 2. And we get negative 7x minus 8 y minus 2 equals 13. And we want the y-intercept, so we're going to plug in x is 0, so this guy kind of goes away. And we get negative 8y plus 16 equals 13. Subtract 16 from both sides, we get negative 8y equals negative 3. Divide both sides by 8, and we get y equals 3/8, which is 0.375. Either of those would have been acceptable. Let's check it on Desmos. So negative 7x minus 8y minus 2 equals 13. And the y-intercept is 0.375. Okay, great. We did a good job with that. It seems, just double check, k is 2 because it's up, positive 2. Y minus k, that's y minus 2. Then we replace the y with y minus 2. Very good. Okay, doing good here. All right, this is a tricky one. We have to go right 1 unit and down 3 units. Okay, so h is right 1, so that's positive 1. X minus h is going to be equal to x minus 1. Then we're going to go down 3 units, so that means k equals negative 3. So y minus k is going to be y minus negative 3, or in other words, y plus 3. Now we're going to go and plug these guys in for x and for y. So we get 6 x minus 1 plus 3 y plus 3 equals negative 19. And we want to find an x-intercept, so we're going to plug in y equals 0. So okay, so we get 6x minus 6 plus 3 times 3, which is 9. So 6x, negative 6 plus 9 is 3. Now we're going to do subtract 3 from both sides, and we get 6x, it's negative 19, equals negative 22. And now we're going to divide both sides by 6. And we should get x equals negative 11 over 3. Negative 22 over 6, but it simplifies to negative 11 over 3. Let's see if we can check it using Desmos. So, okay, so just double check. H is 1, that's right. X minus h, x minus 1. Good. K is down, negative 3. Y minus k, y minus negative 3, y plus 3. Good. Seems like we did a good job. 6 x minus 1 plus 3 y plus 3 equals negative 19. It says negative 7.333, and you could type that in to a grid-in, a student-produced response. Or if it's repeating decimal and you see what the pattern is, just go over here and type it in a bunch. Ooh, did I do something wrong? Maybe I did. Oh, that's the y-intercept. We want the x-intercept. Negative 3.67. My bad. So go over here and type in negative 3.666666, which is negative 11 over 3, which is what we got. Good? All right, almost done. Let's go back over here. Okay, so very first thing, I'm going to find out the original vertex. So I'm going to circle these two numbers. Keep, change. So the old vertex is negative 3, negative 8. That 3 had to get changed to a negative 3. The new vertex, they tell us, it's 1, negative 5. And now we're going to do new minus old. So 1 minus negative 3, that's positive 4. And the y direction translation, or k, it's going to be negative 5 minus negative 8, which is positive 3. So 4 in the positive x, and 4 in the positive, and 3 in the positive y. D looks really good. I wrote this down wrong, my bad. This one is change, keep. So we change that one inside the function, inside the parentheses. I still think the work is right. Negative 3, comma, negative 8. Good. All right, let's look at 9. We're going to do this on Desmos, but let's do it without a calculator just for the sake of practice. So f of x minus 5, that is, remember, f of x minus h plus k. So that is an h of change that sign is 5. So that's 5, right? Is our translation? And we're now going to go and find the x-coordinate of the vertex, also called h, using negative b over 2a. So h is negative 72 is b, 2a is negative 4. So we get 72 over negative 8, which is negative 9. So now our old vertex is negative 9 something, question mark. And we're going to shift it 5 right. So we're going to add 5. And our new vertex is negative 4, question mark. So our answer is x equals negative 4. As I was talking about during the slides, guys, these ones, and in my other videos, these ones are much easier to do on Desmos, so let's do that right now. So f of x equals negative 4x squared minus 72x plus 7. We don't even need to figure out the translation. They told it to us. The function notation. They just gave it to us, which is nice. Okay, now I look for the vertex. It seems to be up here. And the x value of that vertex where it reaches its maximum is -4. Looks good. Okay, let's do question 10. Okay, so the original center is, there's no number here, so that's just 0. And then this one, we have to change the sign. So it's not 0, -6. It's 0, +6. And we want to shift it down 3 units. So that's 3 in the -y direction. And our new center is going to be 0, 3. And the radius, remember the right side is r². So the square root of 81. The square root of 81 is 9. So this has a radius of 9. So our answer should also have a radius of 9 as well. So we want one with a center of 0, 3 and a radius of 9. So let's go through the answer choices. First off, right away, I'm noticing that this guy has a radius of 3. So he's wrong. Because the square root of 9 is on the right side. Square root of 9 is 3. So he's wrong regardless. This one has a center of 0, +9. Change the sign. This one has a center of 0, +3. Change the sign. This one has a center of -3, 0. Seems like the only one it could be is the one with 0, 3 and the correct radius, which is answer choice B. All right, let's go back to the slides. Okay, everybody, thank you for watching. Please comment below your thoughts on the video and worksheet. Did you find them helpful? Like the video and subscribe for more digital SAT math content. And if you need tutoring, my website is linked in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.